Hello, everyone, and welcome to the Canadian Electricity Association's Conversation webinar series. The Canadian Electricity Association is the voice of the industry in Canada. My name is Dave McKendry. I'm Senior Fellow with the Canadian Electricity Association. I'm pleased to be your host for today's webinar. The Conversation series features presentations from CEA's corporate partners and highlights a variety of Canadian and international solutions to current and future challenges faced by the industry. Working with CEA's corporate partners, these webinars have been developed to be of specific interest to those working in the electric utility space from generation through to customer. For a list of upcoming sessions, please check out CEA's website at electricity.ca. These webinars allow a broad national audience to participate at low or no cost without the need to travel or invest a lot of time. We are broadcasting from Ottawa to over 65 locations across Canada today. Before we get started, here are a few housekeeping items. Our session is scheduled to run from 1 p.m. to 2 p.m. Eastern. Questions can be asked, and we would encourage you to do so as they come to mind by typing them into the chat feature on your screen. They will be asked at the end of the presentation. We'd ask that you also please set your device to mute, and a brief survey will be sent to webinar participants at the conclusion of the session today. We very much appreciate your candid feedback and are interested in any topics that you would like to have included in the conversation series. Please keep an eye out for future webinars and events through CEA's monthly newsletter, Current Affairs. With over 6,000 subscribers, Current Affairs is much like the national newspaper in the industry. It's the place to go for Canadian industry news, and we connect there the national value chain from customer through to the generation side of the business. If you would like to receive Current Affairs, you can subscribe by going to CEA's website, electricity.ca. Today's topic is how non-wires alternatives help Nova Scotia Power weather the worst of Hurricane Dorian. As customer expectations of their utilities increase, which include adopting clean energy solutions that improve reliability and offer more value for their dollar, Nova Scotia Power has chosen to invest in more distributed energy resources, or DER, to help transform and diversify their fleet of energy generation. The value of distributed energy came to light when Hurricane Dorian hit last year, as residents with Tesla batteries had nearly 19 hours of battery backup power. This feeder-level microgrid project will shed light on how to pair distributed energy with the right software systems to meet a variety of objectives, like managing peak demand, smoothing renewable generation, evaluating non-wires alternative solutions for grid services, and in combining intelligent planning and distributed energy management to scale distributed energy programs. Our presenting corporate partner today is Opus One Solutions, and our presenters are Harry Subramaniam, who is Chief of Strategic Growth, Opus One Solutions, and Jill Searle, who is a Smart Grid Manager, Program Manager for Nova Scotia Power. Harry and Jill will turn the webinar over to you.
Thanks, David and team. I'm joined by Jill to kick off the presentation. We'll try to run through some slides and questions for about 15 minutes. Feel free to ask them also in between the junction as we kind of pause. To start off, from an agenda perspective, to introduce Jill and myself and the companies that were from Opus One and Nova Scotia Power, a bit about non-wires alternative, and really to move into the journey of Opus One with our customers and our partners, and the evolution of what was distributed resource management as it moved through non-wires alternative, and where we are today is the use of non-wires alternatives from a regulatory standpoint, cost standpoint, but also for the ability for utilities who are under pressure to provide the best resiliency possible to their customers while ensuring that the system has integrity and profitability there. So we're going to talk a bit about the problem, the journey, some projects, also a bit outside of NSPI. That was the first results, and then some next steps. Well, since we are at COVID times, I would ask Jill to kind of talk a bit about what it is to live in the Atlantic bubble. I am on the West Coast in Banff. bit about me. I just walked through, I guess, Chateau Lake Louise yesterday. Realized that it was burned by a fire, but also realized that Fortis Alberta, who's one of our customers, actually supplies electricity to this beautiful part of the country. But over to you, Jill, in terms of an intro, but also what it is to be part of the bubble today.
Thanks, Harry. Yeah, I'm speaking with you from about an hour south of Halifax today. And as Harry mentioned, he would like to get back down to visit our utility and our project, but unfortunately he would then have to isolate for 14 days. So we're doing fairly well at this end of the country. School has started today, and kids are actually in class. So hopefully things go well. Although from a Nova Scotia Power perspective, majority of our office staff have been working from home since March.
Opus One. Just moving into a little bit about us. We have about 20 plus customers globally, headquartered in Toronto with 2 offices. We have an office down south in New York and one opening up in Glasgow in the COVID year. Not all of our customers, but some of our customers. We've got some great partnerships around the world, and we're one of the I think 3 times in a row Cleantech 100 recipients from a Canadian perspective. And then we're invested by venture cap funds. And we're about 70 odd people and growing, and we hope to hit about 100 in about 2 years. And most of our tech is patent protected, which makes us unique as well in the landscape. Jill?
Yeah, so Nova Scotia Power is our utility. We provide power to about 95% of Nova Scotians. There are a few municipal utilities that are in the province, but we're a vertically integrated investor-owned utility, and we are regulated by a provincial regulator through a regulated monopoly situation, which comes into play later when we talk about our project. We have about 500,000 customers. We're right in the middle of a smart meter rollout to our customers all across the province and are hoping to be completed by early next year. And what's important to take away from our stats here is that we have about 2,400 megawatts of generation installed on our system, and of that 600 megawatts is wind. So that comes into play when we're considering how we're going to operate our system and be able to respond to intermittent renewables.
Just moving into the topic of today, what it means by the term non-wires alternative. This is a Navigant report. It's an electricity grid investment or project that uses non-traditional solutions such as DGs, energy storage, demand response, and software controls to defer equipment upgrades, reducing load at a hub station or circuit level. Now, the beautiful thing is what Jill is going to talk about. The project actually embodies pretty much all of it in a cool construct. Probably this project was designed well ahead of what NWAs were even termed, and early stages, I would say. Where are we today? I think everyone is sandwiched. So the view from the bottom, from a consumers, is they think the cost of electricity across the country is going up, and they'd like it to stop. Regulators and political stakeholders feeling that pressure come from the top. Their goal is to ask the regulators to keep rates low, which means do not give utilities permission to increase rates or ask more questions from interveners by doing so. From a company standpoint, obviously, that puts utilities who are our partners with expectations, but no wiggle room. The expectations are still to keep the reliability of service, still to ensure that everything is moved into the OPEX budget, which you have to pay for from a utility perspective out of your own pocket, which you can't capitalize. Your costs are increasing because technology, whether it be hardware or software, is incrementally increasing. And then if you are a regulated utility, then how are you able to meet profitability goals? I should pause here. Obviously, there are 3 or 4 utilities in the country, Saskatchewan, Manitoba, BC, and Hydro-Quebec, where they're completely owned by the province, where the provincial regulator or the government of the day may say just break even rather than making profit, thereby ensuring the cost levers are lower, but that still means you still have reliability of service as one of the mainstays. Now, this is, I think, where we are today, where utilities are sandwiched. Now, what exacerbates this is natural disasters like Dorian or COVID in terms of pressure on the public purse, and therefore anything that the government and the regulators may want to ease commercial or residential rates would probably have a harsher impact in terms of rate cases moving forward. Thus, we believe today NWAs may take far more of a robust swing in terms of either regulatory mandated or forcing utilities to come out with multiple models that we have seen in the UK. But just kind of moving on to some of the problems, obviously, the picture on the top left is Alberta in the last 2 years of forest fires. On the right is Ontario during the ice storm. And then on the lower left is Dorian as she swept through to Nova Scotia. And then what we often hear about today is bankruptcies caused by natural disasters of utilities. Obviously, I think Canada is quite well shielded, but nonetheless, it's the reality of what is perhaps yet to come if climate change sweeps through and so on. And how do we kind of address that using technology, but also how do we do it in a cost-effective manner? So the journey, we started with Nova Scotia Power in 2016 because it was first of its kind. It took a while. They also gave birth to our DERMS platform coming online. And then there's about 5 other projects that we'll give a quick snapshot on in the evolution of software controls, but also moving from DER implementation, boots on the ground, to DER software, but rather moving ahead of it to planning. And in doing so, it's not only assets owned by the utility, but also assets owned behind the meter that you can harness. Right? And then the regulatory asks that we're seeing in some jurisdiction, the mandates, particularly being UK and then also US, and the evolving incentive mechanisms certain jurisdictions are looking at to incent utilities to look at NWAs. So it's not seen as an anti-capex initiative, but rather it is a prudent initiative, but how do you ensure that profitability is still there from a utility perspective? Jill, I shall pass it over to you to talk particularly about why we're here today, which is the Intelligent Feeder project, about the project, the regulator, and the use cases.
Sure, thanks, Harry. You just want to advance the slides. So the Intelligent Feeder project was brought about by, I think, in response to some of our context at the time in 2016. In Nova Scotia, we have a mandate to be 40% renewable by 2020. And we're primarily a solid fuel generating utility. We have limited hydro availability to us, so we are trying to expand our hydro accessibility by, we've built the Maritime Link, which is a subsea cable between Newfoundland and Nova Scotia. We are waiting for the completion of Unit 3 of Muskrat Falls to be able to start flowing hydroelectricity from Newfoundland, but that will then provide us our 40% target. And of course, policy, we now have a 0% emitting by 2050. So as we move forward on these more aggressive renewable targets and non-emitting targets, distributed energy resources is going to be one of the answers, one of the solutions to the problem. So if you want to move the slide ahead, Harry, we've got the next slide, which shows why it's an issue in Nova Scotia and why I specifically mentioned the 600 megawatts of installed wind capacity. This is a shot from the SCADA screen in the control room on the coldest hour of the coldest day of the year. I think it was February sometime. And if you look at what's online, if you want to advance the slide here, you can tell that when our total load requirement of 2,100 megawatts is on the system, at that time, only 54 megawatts of the 600 of wind were available to us. So the question is, and it's not just our question, but it's a question for utilities, generators everywhere, is how do you make that renewable energy dispatchable? So that's why we were interested in piloting a storage project to see what the value would be for the utility and what the value would be for our customers. Next slide, Harry. So enter the Intelligent Feeder project. We were approached by Opus One to be a demonstration location for them. They were developing their Grid OS software, and we were interested in piloting storage in combination with intermittent generation. So we developed a feeder level microgrid that involved installing a Tesla power pack at a substation and also some power walls that are on the same feeder at customers' homes. We have 6 megawatts of wind, a distributed wind on that feeder. And we had to install a sectionalizing switch because economics dictated the size of the battery that was available to us. So we had to limit the size of our microgrid based on the battery that we could afford at the time. We didn't at the time have smart meters or any real situational awareness on the feeder. We do have a recloser communicating at the head of the feeder, but we wanted to install line sensors across the feeder to get some baseline data and operational data during microgrid operation. And all of that information is brought back to our control center where our distribution system operators are using Grid OS to action the microgrid in response to the grid system. Next slide, Harry. This is a virtual tour of our Intelligent Feeder project. This is the power pack located at the substation. There are 25 Tesla power pack battery cabinets and 2 inverters that are installed. And because that is located in substation, we had to have utility grade connection equipment, step-up transformers, this underground switch to an overhead primary disconnect switch that's motor operated and operational from our control center. We also, because we're operating the system in a microgrid, had to have a grounding transformer that provides a neutral reference when we are islanded. Next slide, Harry. So this is a view of the feeder where the system is located. The substation's at the bottom of the screen, and you can see it's quite a large rural feeder that's radial. The 6 megawatts of wind is located almost at the extent of the feeder, and we deployed our line sensors throughout the whole feeder for information baseline and background. You can just advance the slide, Harry, I believe that builds. And then we also have the next image will show how much of the battery, the feeder that the battery would support if you advance it one more time, Harry. You can see it's not much. So this is the sectionalizing recloser is actually just up gradient or upstream of a sportsplex that has 2 ice pads and a blow-up soccer dome. So that load was limiting as how far we could build our microgrid. But we can support about 300 homes. The power pack has a 2-hour peak duration, but we do expect that in the summer, if we had to action the microgrid, the load's light enough that we could provide backup power for that whole section for much longer. Next slide.
And Jill, if I may add, there's
Sure.
always been a concept of grid of grids. So a lot of people said, islanding grids add resiliency and you have a concentric circle. And I think at Nova Scotia, what you've designed is Elmsdale. And if you choose to proceed, and if there's a business case, you could sectionalize grids as you move forward to add resiliency as well.
Yeah, absolutely. Again, continuing with the virtual tour, this is what the power packs and inverters look like and the site master controller on the left of the photo. Next slide. I should mention it was a 1.25 megawatt 2-hour duration battery at the substation. This is a shot of the sectionalizing recloser and the radio link back to the substation for communication and operation. Next slide. The Aclara line sensors that we deployed across the system, the ability to have better discrete numbers on the voltage required a neutral reference. So that was sort of a net new installation standard that had to be developed by our distribution engineering team, but they've been in and operating since 2016. Next slide, Harry. And they do communicate via cellular. And then the 6 megawatts of wind. It's not a Nova Scotia Power generating facility. It is a power purchase agreement that's been enabled through a community feed-in tariff program that the Department of Energy ran in our province a few years ago. And we do have real-time telemetry on their recloser, but not control. Next slide, Harry. So the microgrid itself, I also believe this slide advances, there are 10 Powerwall 2s that are installed on customers' homes within the feeder extent. This project gave us an opportunity to play with both grid scale batteries and also behind the meter residential scale to get a feel for what is the best fit for customers. So the next slide just talks a little bit about the specifications of the Powerwall 2s. Compared to the Powerwall ones, they've got double the energy density and we're the same price. And the Powerwall 2s do have a built-in inverter, where this Powerwall ones required a separate inverter installation. Next slide, Harry. And the way we got our customers to sign up for participation in the project was by sending a letter to everybody on the feeder between the substation and the sectionalizing recloser that would have directed them to a web form if they were interested in participating. We didn't have any demographic criteria. We really were just interested in customers who were interested in our project, and the Powerwalls were provided free of charge to customers. They remain the property of Nova Scotia Power for the duration of the pilot project, after which they would either be transferred to the customer or we could remove them if they choose not to keep them. Next slide, Harry. This is what one of the installations looks like. In this particular case, the customer had a generator panel. And because we are, again, fiscally constrained, the whole project cost about $3.2 million, of which 33% was subsidized by SDTC. We did only provide one Powerwall per home, so it's only a partial power situation. So customers would have had to select which circuits they wanted backed up by the Powerwalls. Next slide. And then the power pack was in and commissioned in May of 2018. Next slide, Harry. And then islanding the microgrid, the testing for that took a little bit longer and some coordination with our distribution control center. We were able to test the microgrid in the middle of the night by offloading the remainder of our customers to an adjacent feeder and actioning the microgrid. The design of the microgrid did not allow for seamless transfer. We figured we wanted to walk before we ran. So there is about a 2-minute outage to be able to take customers off the grid, put them on the microgrid, and then another 2-minute outage where we take them off the microgrid and reestablish grid connection. Next slide, Harry. Some of the preliminary data, the lines on the top are the 3 phases of recloser data at the substation, and the bottom line is what's the output from the 6 megawatts of wind. And you can see that when the wind is generating, there is a clear impact at the feeder head for pushing the energy back. And when something happens to the wind or the generator shut off, then there's some potential impact on assets to the grid where your taps are changing more than you would normally. So having a battery installed with the capability of providing ramping up and down in response to the wind generation signal is also an asset management benefit for us. Next slide, Harry. Some additional benefits. So again, this is before we had smart meters and the ability to provide real-time updates to our customers. So the customers with Powerwalls did have, through the Tesla app, notification of when there were outages and reassurance that their home was being backed up. We would love to have a Nova Scotia Power logoed notification, provide similar information. And the Aclara line sensors that were deployed also provided fault location in the event of outages that we could plug into our ADMS system and figure out where we could send our crews to help with restoration times. Next slide, Harry. And almost unprecedented for some of our utilities, this was a good news story for us. So there's been a lot of interest in the project, and it's been an opportunity for us to talk about ways that we're being innovative for our customers in an affordable way by taking on a pilot project as opposed to a full-scale project. So that's definitely something I'll count in the win column. Next slide, Harry. The use cases that we tested with the system include substation capacity relief, some of the time shifting or peak shifting using the battery. The power pack does have a 4-quadrant inverter, so it can do real and reactive power charge and discharge. And there is a gypsum mine located on that feeder, so there have been power quality complaints in the past, and we've been able to dispatch the battery and support. The renewable support we talked about, integrating with the 6 megawatts of wind and providing backup in the event of an outage. And of course, GridOS is also developed not just for regulated utility, but could also be used to respond to market signals as opposed to just grid signals. Next slide, Harry. So something we're often asked by other jurisdictions is, how did you get your regulator to approve our project? Because we are an ask permission, not beg forgiveness type environment, we have to have all our capital approved in advance. And in 2016, there was no clear mechanism for being able to do an innovation type project. But we did have a directive from our board, the UARB, as Utility and Review Board in Nova Scotia, in response to a capital filing we had put before them to refurbish a combustion turbine. And they were interested and directed us to do some investigation of storage technology options instead of as an alternative to doing traditional generation. So I jokingly, tongue-in-cheek, called it a non-generation alternative. That was the directive from our UARB. But our board is progressive and recognized that there's an opportunity here, and needs to be a capability to be able to approve projects on a timely and non-traditional cost benefit, especially in the case of storage, metrics. So they developed the innovation justification criteria in 2018. So going forward, we are able to put innovation projects in front of our board with the criteria listed on the slide, and they will consider it on those merits. Next slide, Harry. We'll just close on the experience for our customers for Dorian. We did have over 8 days of outages for some of our customers. The customers located on the feeder where the pilot project was had an 18-hour, 54-minute outage. Because of the nature of the protection and control design of the microgrid, it's designed to operate in the event of a loss of transmission or a loss of substation power. It's not designed to work if there's a fault potentially within the extent of the microgrid. And because Dorian was such a tree-related event and the line sensors weren't able to firmly locate the outages, and there were multiple outages, we decided it was safer to not action the microgrid in Dorian. So the 10 customers who had the Powerwalls would have had backup power for the full extent of the outage. Because of the circuits that they chose for backup, they had power the full 19 hours and would have had about 20 to 40, depending on the home, amount of power remaining after the power was restored. So they were quite satisfied with the performance during Dorian. Unfortunately, the other 290 customers did not get backup power from the microgrid. Back over to you, Harry.
Perfect. Thanks, Jill. I think a couple of things on what you've kind of stated. One was that I think you were the first jurisdiction in the country to pretty much ask for this kind of money in 2016 from the regulator and received it. And then the second one was, I think, towards the end, you could talk about, what your expansionist views are in terms of storage as you look at helping solve some of resiliency issues for Nova Scotia Power moving forward. In terms of not to talk about software, but what helped propel us to build what is DERMS, there's so many different types of distributed energy resources. I don't have a slide on, we only play in one of the 6, but very much towards certain specific utilities. It is not built to, scale up to a gigantic utility per se. In its early stages, thus it's very simplified architecture, which worked at Nova Scotia, which was a blending of microgrids and DERMS together, which is a microgrid element. So we were able to island as a feeder, which was one of the first of its kind in the world in the way it was configured. So moving microgrids that we usually know about buildings or resiliency for certain attributes, now moving it into the electricity infrastructure. Then adding DERs, controlling and piggybacking through utility SCADA or historians or AMI, in some cases ADMS, and then how does it pull together into your control room? Really, it's integrate, visualize, monitor conditions, and choose control strategies. Now, I must tell Jill that she has the older version of the software, and we will be giving her hopefully a newer version as the next things come out. So she's been very patient with it. And some of the control strategies in detail, we will share this slide deck with the CEA, but also happy to send it to you by email as well, so we don't kind of go into it. But really, time shifting, some storm preparations, power factor correction, wind power smoothing, voltage, and then more importantly, resilient. Now, as Nova Scotia Power was the first, we've had about 3 or 4 since inception. So some of the use cases that we've added on, and they all kind of move into customers, where the assets are, who owns the assets, and what kind of use case actually lends credibility to the grid or reliability to the grid. So this was Science North was the host with Sudbury Hydro, where here the storage was owned by Sudbury Hydro, but it was at Science North because the customer was facing issues that the utility could not solve, or could sign on a legal agreement that says there'll be uninterruptible power in this scenario. Where here the uniqueness is that it took load off the feeder, but there was no feedback into the feeder from stabilizing the feeder perspective. So it is storage, solar. So it was a microgrid that did a little bit of DERMS capability, if you will. The second one is Lexicon Energy, which is Viridian Connections for all of Durham outside of Toronto. And this is by design. It's a net zero community, 27 homes. And this was designed again where Lexicon owns the power pack in this case. It's a nested microgrid, first of its kind in Canada, whereas the solar is owned by the community, where here it's a hybrid between the utility and the community or the developer coming together to build a new kind of community where they could power themselves off green. There's an EV charger. There is also power walls in this case in home batteries. But at the end of the day, this is a triple layer, 2-tiered microgrid where the power pack can be used by the utility and controlled to put electrons into the feeder to stabilize the feeder. Because there's a substation at the end owned by the transmission provider that causes ripples to this line. So when they looked at it, the cost of this one would have been 10 million, and this project would actually do it for 2.5 million. So almost 75% cost reduction, if you will, in terms of if you were to strengthen the feeder at any kind of levels. And this project is going to finish, I think, Q1, Q2 of next year. This is another one with Lakeland Power in Northern Ontario. This one takes off Jill's project and adds a little bit more nuances because Lakeland owns water heaters. So they wanted to bring DERs that were owned by the utility in the customer's home as part of the matrix. Again, islanding an entire feeder. Their vision is to sectionalize feeder by feeder to make the town of Perry Sound a net zero town in about 2025. Lakeland is a unique partner in the sense that they also own generation assets around that through Lakeland Power and Lakeland Utility. So it's a merging between unregulated and the regulated together to bring about a solution for the entire community. This is Hydro One is another one, mainly around reliability and resiliency. SAIDI scores are critical to this customer, where here the issue was in Ontario, it's hard to put what Jill was able to achieve with the regulators to put Tesla Powerwalls inside customer homes. So as the utilities are still progressing to have the discourse with the Ontario's regulator, Hydro One decided, can we put storage at a node which connects 20 homes, so thereby not entering the customer's homes. So in this case, again, it was Tesla Powerwalls, a power pack that was at the central node to say, can it serve as backup to 25 homes? There's 2 projects in Northern Ontario in the Muskoka region that has been ongoing, and I think they'll be in service next year. Again, this is under the purview of the Ontario Energy regulator, and this could be part of their innovation sandbox projects as well. But right now it's funded by the regulator as a small piece. And lastly, I know we're talking about Eastern Canada, we've talked about Ontario and Central, but moving to West, where I am at the moment, is with Fortis, Alberta, with the town of Waterton, which was one of the towns that was fire ravaged about 2 years ago from the wildfires between BC and Alberta. This is unique where this solves the problem differently. You still have storage, but at the substation level, but the feeder line is about 70 kilometers to the town. So it's long radial feeder line. But where the storage in this case is on one side on the substation, solar will actually be close to the town itself, 70 kilometers away, and using software to stabilize, and then looking between traditional wire investment versus non-traditional wire investment, and they're quantifying the savings. So in this case, it's a spread of around 2 million as we embark the project. So this is just kicking off as we're having this conversation. So all to say, different modalities of non-wires alternatives, different typologies and what the regulator wants to achieve, but also what the utility and ultimately customer benefits kind of come into play. Now, these are all bricks and mortar projects with some software. The key here is that as we were going on this evolution, Opus One as a company started to move into planning, so not the SIME synergy version of planning, but rather looking at non-wires alternative planning that could help utilities come up with these solutions, quantify them, go to the regulator to get the money, and then actually implement them. So that gave birth to what we call IDP platform. So Jill is a foreseer in this case. She actually did the quantification, got on this project. 4 years later, people like us follow the lead and reverse engineer that project. So most of the project I talked about were actually reverse engineering to see, will our platform have pumped out the same solution or a better solution? Key being output, analytics of data that we used for management decisions, but more importantly also for regulatory filing with the respective utilities. So currently the non-wires alternative modeling is about a deconstructive approach. It has non-wire screens. They evaluate DER's technical potential. They rank the non-wire solutions, and they create a non-wires resource stack, going to the lowest cost potential. Most of them are done by consulting firms. Some are done by utilities. Our goal was to make it simpler. And where we moved it to is the reliance on non-wires on the current approach to us not making any conclusions, but rather doing a time series evaluation, tools to expedite the amount of time spent. So one of the things from an OpEx saving was really good engineers were tasked internally when we worked with our customers on doing just data crunching and Excel spreadsheet that took away precious time from them that they could actually be doing the engineering work. So this is designed to unlock some of that potential using the time of an engineer to the full extent. And the idea is that they're built on network models built up over time, and everything's kind of layered on so you have a nice track. I'm not going to go into details. There are more slides we're happy to send you. But just kind of a snapshot of what the screens look like. How do you create a business case from a technical and economic feasibility? You do comparisons, and then you do violation breakdowns. Since you're using your entire network model, it's as real as it's going to get. And a cost benefit analysis, which goes to the regulators or internal decision making. One of the things I do want to say here before we run out of time is that from an Opus One perspective, we're running a bunch of projects across the country. A lot of utilities have participated. Jill is participating on an electric vehicle planning study. If anyone on the phone after this, if you're interested in saying, listen, I'd love to do a non-wires alternative, just even if it's a scenario or a study, do let us know. We're happy to do it pro bono, just to see if it adds value to your jurisdiction. I'm particularly interested in Saskatchewan, BC, and Manitoba as well. Just because those jurisdictions are unique in the way the regulator, I think, is asking to look at NWAs. In summary, I think, Jill, can I turn it over to you from an NSPI perspective, and I'll kind of finish up.
Sure, Harry. Yeah, the project is still ongoing for us. We've completed all our use case testing with the Power Pack, and the functionality through Tesla to be able to do utility and fleet control of Powerwalls became available in November of 2019, and then through the COVID, it has definitely slowed down our ability to do further use case testing. So we're back in the running on that and hope to have everything in and completed by the end of this year. There's been a lot of lessons learned through the whole project. I think we came into the project not really having a great idea of the amount of effort and integration required. We thought we were just installing an asset and operating it, but of course it's never that simple. And Opus One's been a great partner to help us work through all those challenges. The ability to have the control of the germs is absolutely something that our control center is interested in. And knowing that the proliferation of DERMS will be more instead of less in the near future, we are looking at other projects to do testing on other DERMS, as a lot of acronyms. As Harry mentioned, we are looking at doing the planning testing for electric vehicles through the IDP program. We're also looking at we are participating in a NRCan project for a Smart Grid Nova Scotia, which is part of the Smart Grid Atlantic initiative. And moving forward, the question I'm asked most often is, okay, so what does this mean? Will be there more batteries? And the answer, of course, is it depends. There does need to be a clear business case for it. And that's something as a vertically integrated utility that we don't have a clear market signal that says yes or no for us. We need to continue to do the analysis to figure that out. Back to you, Harry.
Thanks, Jill. I think as we kind of lead on for IDP, as I said, we've done a reverse analysis and now moving to forward planning analysis. So we're running an initiative globally with about 15 customers, stateside, Caribbean, Europe, Asia, and then obviously Canada being a homegrown country. So feel free to contact me or Jill once this is done. Just quickly on regulatory drivers, what we've been monitoring is from a North American standpoint, NWS has been talked about quite a bit out of CEPA and Gridwide Alliance for about 5 years. A lot of projects stateside. We're seeing 2 or 3 jurisdictions in the US explicitly asking utilities to submit a traditional rate case and a non-wires alternative rate case. The question is, will they stick and what does it mean? They're asking for analytics. So we're kind of working with some of our customers to see what analytics are the regulators after. Those are the ones from the state side we have. From Canada, we've seen on and off, but there's been movements, but not really in terms of cost drivers. We do believe that in Ontario, with the reg changes, this could become something that the regulators ask for, but it's TBD. Globally, however, it's a very different story. We work with Singapore Power. Their infrastructure is aging. Obviously, it's a small city state, so one regulator, one utility. There, the regulator is imploring the utility to come up with analytics on asset management as well as asset health, and then planning in terms of rate cases. UK is the most unique because their regulator kind of moved out about 5 to 10 years ago, changing the model where they call it TOTEX and now it's RIO, which is their transformation piece. Where now what they're saying is, you know, please give non-wires alternative. I want the lowest case versus the highest. But what we'll do is if we pick the lowest case, we'll actually give you the rate of return of not, let's say 9%, but rather 12%. So there in UK, what they have done is they've created an incentive for utilities to actually capex less, which means lowering the rate base and the rate case in December edition, but rather ensuring the utilities still make money on the lower capex model as opposed to a higher capex model. I know a lot of regulators are studying the UK model, but I think this is probably a wave that will continue as chips fall differently across the globe. One of the other things per jurisdiction that we're seeing is the pressure of, I think, mainly by entities who are investing at the edge of grid, going to the regulator and the politicians by saying their investments are still stranded, that it could be cross-monetized or used should the utility be given the ability to use their investments for grid benefits. So we've heard a lot of chatter on, you know, can you harness somebody else's investment? How can the utility still get the certainty, but also provide the reliability and resiliency that's part of their core mandate? So I think that evolution of that will also change this evolving landscape. That's it from me. I think David and team, we have 16 minutes. for questions and discussions.
Well, thank you very much, Harry and Jill. I found that whole presentation really, really fascinating. It's some great piloting that's going on. Jill, congratulations to the leadership that Nova Scotia Power is showing in this area. Harry, thank you for the leadership that you're showing, not only in Canada, but worldwide with the Canadian success story. Absolutely wonderful. We thank you very much. We do have a few minutes for questions. We do have some questions that have come in. And I would encourage you, as our viewers, if you've got a question, please just move to your webinar screen, and you can tap in your question there. And we'll get started with the first one. Jill, you might be able to answer this. The question was simply, what voltage level is the pilot at?
Yeah, it's on one of our primary distribution feeders at 25,000 volts, 25 kV. And that's the very large step-out transformer that was in the photo.
Great, thank you very much. The next one up, and I don't know if this is Jill or Harry, the question is the ability to scale up limited by battery technology or other factors?
I think maybe I'll answer Jill first. No, I think you can scale up using multimodal technologies, whether it be owned by the utility or owned by external assets. So it's not only battery in our view, it's agnostic to whether it be solar, whether it be certain people have micro cogens, some people have standby gas generators that could be used. So it's agnostic from a scale up perspective, but particularly to Nova Scotia Power, Jill, I think you may prefer one over another.
Yeah, we're definitely looking at options for many distributed energy resources. The Smart Grid Atlantic and Smart Grid Nova Scotia project I mentioned, we're looking at utility control of EV smart chargers. We do have some more residential, commercial behind the meter or around the meter storage that we're looking at as options. We're also looking at deploying solar and storage paired in larger facilities like commercial industrial applications where from a grid perspective, you get a little more bang for your buck. And the other thing we're looking at is it has to do with customer programming, but we're installing a 2 megawatt solar field with the plan to have like a virtual net metering or the ability for customers to subscribe. Really just to get a feel, again, similar scope, what's the value for the utility and what's the value for customers, because we know the future grid looks a lot more participatory from a customer perspective.
Great, thank you very much. Next question. It says, hi Jill, you mentioned there was a split for capital funding of the project. Could you tell us more about where the capital funding came from? Also, if there were upgrades required to the customers' homes to install the power walls, and if so, who paid for these? For example, upgrading from a 100 amp panel to a 200 amp panel.
Sure. Yeah, the first part of the question around the capital funding. So we would have an annual capital program that's approved by the regulator, and this project was submitted as a project in sort of the larger group of projects for approval. So 33% was funded from Sustainable Development Technology Canada's Clean Energy Fund that Opus One was the prime applicant for, and the remainder would have come out of our capital projects fund, which is paid for by our customers. The second part of the question was around upgrades. So again, I alluded to having a web form that customers would have filled out, and we would have then sent a technician or an electrician to the home to do an assessment. One of the criteria was we didn't want to have to do any upgrades to participate in the program. So there was no construction. We didn't have to make any walls bigger or anything like that. And that did limit participation for sure. And I will say one of the inadvertent lessons learned that we unfortunately came from this project was we did specify a 200 amp service, and that was in an effort to not have to do the upgrades. But what that ended up doing is only newer, nicer, air quotes, homes are 200 amp services. So it sounded to the locals that we would have only given free power walls to rich people, direct quote. So that absolutely was not our intended outcome. And we have subsequently learned that the power walls can be installed on a 60 amp service. So in the end, it wasn't necessary, but if we had to do it over again, that would not have been a criteria for sure.
Great, thank you. I guess probably Jill, for you again, how does Nova Scotia Power and I guess other utilities typically bill the customers for the microgrid usage?
Yeah, there's no direct charge based on the microgrid or any of our capital projects. They would be a blended part of a rate case, so it would not be a separate allocation. The next phase of the project, the Smart Grid Nova Scotia project, will look at customer participation, both compensation and capital contributions for either an installation of a Powerwall or the ability to control the EV chargers. So that's the next level of development for us, is figuring out that value and how we would bill for it or credit for it.
Right, thank you. Next question is, will this webinar be available for later viewing? And the answer to that is yes. Actually, as a registrant of this webinar, you will automatically be getting a copy, and we look forward to also posting it within the CEA as well. Next question is the microgrid between the substation and the sectionalizing point, or from the sectionalizing point to the end of the feeder?
It is from the substation to the sectionalizing point. So the 6 megawatts of wind are not included inside the microgrid. They are being used to charge the battery or discharge the battery when the wind's not blowing for the full feeder support. The project is used probably, well, 98% of the time in a grid connected state, and it would only be in the situation where there was a transmission or substation outage that the microgrid would be enabled.
Thank you. Next question. Regarding the innovation criteria established by the UARB, is all of the funding for a project that is approved under the criteria eligible for a regulated rate of return? And has Nova Scotia Power secured approval for other projects under the innovation criteria?
Yeah, the first part, I believe, yes, that would be fully recoverable. And yes, we have one project that has been approved under the new innovation criteria, and that is the Smart Grid Nova Scotia project.
Thank you. Next question. What manages the stability of the microgrid, voltage, frequency, etc.? A field device or the Grid OS platform?
We do have a relay at the substation. I'm not going to try to talk over my depth, and I can definitely bring this back to our electrical engineers. But the Grid OS is dispatching the battery. It is taking all of those, the frequency and voltage inputs, and actioning. So it is through Grid OS when Grid OS is enabled. As a backup, we do have direct SCADA control of the power pack at the substation as well. And we have not yet been charging or discharging the battery outside of Grid OS, but we do have that capability.
Thank you. Next one is basically a comment. Great presentation. Thanks, Jill and Harry. I've got a question, and I'd like to, same question for both of you. Maybe Jill will go with you first, and then Harry. I'd be curious, with this project, what was the biggest thing you learned, and what was the biggest surprise?
I think, Jill, you may want to go first.
Sure, wrong button, turn off the camera instead of unmuting myself. Technology. I would say actually our customer participation was the biggest challenge and eye-opening piece for me. So, you know, we would have contacted almost 200 customers to participate in an exciting innovation project where we were giving them a free Powerwall, and we had probably 24 folks who came back through the web form. And once we went through the process and there's a customer agreement that needed to be signed, we had lots of people drop out and decide they didn't want to participate. So I don't know if that was a distrust of the technology. It could be a distrust of the utility, but that's definitely something that we need to dig in and understand. The other, I think, technical learning for us was really around the fact that, you know, we have a lot of distribution devices in the field that are manually operated. You install them and you lubricate them and they're good for 35 years. Now we've got systems that require software updates every few months and require, you know, you have to reboot literally IT support, reboot the site master controller every now and then to make sure you've got connectivity. And the level of integration effort and sensitivity, I think, of having an IT or based smart grid is really was eye-opening for us.
Great, thank you. And Harry, same question to you. Biggest learnings, biggest surprise?
Well, I think the biggest learning for us was, no, it was surprise, but I mean, it takes time to put this together. So kudos to Jill and the team in terms of, I think, the first one at that time to put a power pack in the country. And also, you know, dealing with the weather in the Atlantic coast during the winter. So I think a couple of those nuts and bolts aspect. But also, I think field testing the software to making sure the linkages worked. So a lot of good learnings from that. And lastly, I think I was over, the team was visiting Jill's team. So to me, I think after Jill has gone through the tough times of qualifying about 20 odd participants, I think they installed a Powerwall to a client, and I think it was Rob Boone who was there. And I think the client was texting him because they were just so happy that they had a cool object and that it was going to power their homes. They were ready for testing. So what I saw was a bit of excitement of that one customer who really wanted to be part of it. And I'm glad during Dorian that it worked for them.
Well, that's terrific. Well, I note that we're reaching the top of the hour here, so maybe we'll just take a moment, Jill, to thank you for your time, and Harry, thank you for your time as you've taken us through the background, the backdrop of what this project has been all about, and what the results you've seen and where you're going with it. It's been very, very fascinating. We thank you for that. So with that, we'll close off this particular webinar, and Jill, you can go off screen now if you'd care. So we'd also just like to ask our listeners and viewers to mark your calendars. Our next conversation series webinars will be held on September the 10th, so that's this Thursday. Hatch Limited will be speaking to electrical distribution grid continuity given COVID. And then on September the 17th, the week after, Oracle Utilities will be presenting electric utilities post-COVID. What's next and how should utilities respond? So you don't want to miss those particular sessions. And if you haven't registered yet, you can do so by going to CEA's website at electricity.ca. In closing, I would once again like to thank Jill and Harry and each of you for joining us today. This concludes today's conversation series webinar, and we'll talk to you next time. Bye for now.